Hi, I'm Maria Greicer here. I'm a VP Partnerships at Keymakr, and I've been part of tech startup industry, specifically AI-based applications for last 18 years. And I'm going to share with you how medical AI is affecting us right now and how it's going to shape our future in the next few years.
You're listening to the Good Question Podcast with Richard Jacobs. Our goal is to make each of our guests exclaim, that's a good question. I don't know the answer. Because when that happens, it means you, the listener, may be inspired to learn more beyond the interview and to ask great questions yourself that lead to new insights. In this podcast, we cover historical and current anthropology, comparative religion, and history. Welcome, and let's get started.
Hello, this is Richard Jacobs with the Good Question Podcast. My guest today is Maria Greicer. We're going to talk about machine vision AI application. Maria is a seasoned executive with over 18 years of experience in AI-driven technology and applications. So welcome, Maria. Thanks for coming.
Thank you. Pleasure to be here.
Yeah, tell me a bit about your background with machine vision AI. What are some really interesting things you've seen develop over the past, 18 years?
Okay, well, of course. So let me start a little bit with my background. So I've been working in startups all my life. That's like the only thing I've been doing so far. Technology startups. So really, it has been very interesting to see the development of the technology and like what we were busy with like 15 years ago, 10 years ago, 5 years ago, and what we're busy with right now. There is really so much advancement going on, and the pace of the development, the pace of the innovation is accelerating. Like the more we live, the faster things change. That has been true so far, at least from what I have seen. And
Please keep going with your background. What are some of the really, interesting things you worked on? And then we'll get to what you're working on today. Okay.
so there are multiple medical advancements that are, medical field has been an important field in our lives so far. And there are many different verticals in medical AI specifically that are being developed, like medical AI or medical technology. My favorite, I would say, my favorite applications, and also that what I specialize in is visual AI application. And what is being developed right now in the medical domain is absolutely amazing. And I would like to share it in a little bit more detail. But before we dive into this, I just want to do like a little comparison to how things have been done so far in our modern world and how they are starting to be done and what's actually the difference that AI, medical AI brings. Like what makes it so unique, what makes it so important and incredible.
Well, let's jump in. What are you working on right now?
Okay, so right now, multiple medical AI applications. For example, if you look at the CT scan is being taken in the hospital, or X-ray or MRI scans, like everything that's visual. So those visual images, like those visual images, so far needed an expert, radiologist, cardiologist, or whoever the specialist is. They needed an expert to look at them and to understand what's going on and basically determine the pathology, determine like what's if there's something wrong or if everything is okay on this image. Right now, all this is being replaced by AI, and basically that's kind of looking in to what we do. Keymakr, we are a building block in creating those types of applications. We provide training data. We train those models. We create custom training data for those models. But what I would like to elaborate is that kind of talk a little bit more about is how this actually, like how different it is from what we knew and we've been doing so far to what's going on right now. So for example, if we take traditional medicine, how it's been working so far. So if we have a doctor, for example, it doesn't matter, like any specialist, and the specialist, even if it's like the best specialist in the world, it's one person. So this person has certain number of patients he's seen so far. He has certain number of years of education, things he experienced in his life. So it's good. So let's say when we go and see the specialist, we get pretty good expertise of one person. Now, if the same diagnosis, same expertise is given by AI, let's say on the same scan, for the same image here, instead of one person, even the best person in the world, we tap into the intelligence and knowledge and expertise of the hundreds of thousands of different experts all put together. So it takes the whole medical examinations and understanding of the condition to a completely different level. So you're not just working with the best expert in the world.
How many images have you fed to an AI on training data, let's say, to identify lung cancer? Millions?
So yes, yeah, I understand what you mean. So it really depends on the model. Usually there are different models that try to do the same, different companies that develop those models. So it takes like thousands of images that are annotated, multiple specialists to train a model properly. Now, and this is not a process that just you do it one time and that's it. No, it's ongoing process. It's constantly developing, which means that like doctor has to go to courses and go to seminars and read papers to constantly keep his knowledge up to date. Same with AI. It has to keep learning. And here we're learning not from one person, we're learning from thousands of experts.
So what kind of things are you seeing? What are some examples?
So, for example, brain tumors, identification of brain tumors, early identification of brain tumors that is done immediately, done with very, very high precision. Another, actually, I would say one of my favorite examples is ultrasound and ultrasound in emergency rooms. And what's happening here, the velocity of the response is very important. So identifying if there's free fluid for or any injury on the ultrasound and identifying it fast, super important to save lives. So when we have a person doing it, there's a delay in the response. It also depends on like the availability of the person. But when we have AI doing it, right now it's starting to be implemented in multiple emergency rooms. It's immediate and it's way, way more precise. So here we're actually seeing like significant impact, measurable impact on AI systems.
So I mean, what is the AI looking for? So what is its diagnosis rate compared to doctors?
So when you're looking at an ultrasound, it's like ultrasound, for example, it's like a lot of things going on. So the AI would recognize the same free fluid, the same like internal bleeding as part of an ultrasound. It would know the area right away. So it would know to recognize that this is internal bleeding with way higher precision, accuracy, and way faster than a person.
Well, what is way higher and way faster? What are some numbers?
Well, I cannot tell you exactly the numbers, how like AI, it's immediate essentially. It looks at the ultrasound and it's there. While for the person, it might take a few minutes till they see it there. And also they might miss it because there's always...
Well, what's the background efficacy rate? And what is the rate with the AI of detection? Like the false positives or false negatives?
I cannot tell you that exactly, but because like we develop the system, we don't implement it, but it's significant enough that it's proven that AI works better.
Okay. So why all of a sudden over the past couple of years does AI seem to be a lot more advanced? What's happened in the field where now you get things like ChatGPT and reasoning modules and all that? Why has AI suddenly jumped up?
So ChatGPT, I would say that that's not part of my domain, so I'll not be able to answer that properly. But in terms of visual AI, like with every technology, we hit like a point in a way, like a tipping point where we know how to train models. We have enough data to train models and it just works faster. It just like more training data, better performing models, and it just works. It's technology.
Are you seeing that in your machine learning or what are you seeing?
Yeah, well, projects that we are working with is machine vision AI only, so it's only visual projects. We see it a lot with visual projects. Like before, well, also when you develop a model, regardless what the model is, you develop it once and then you retrain it. So the older the model is, the more training models went through, the better it gets. So we already have like a few years of training models and creating models, so the models just get smarter. It's like a brain, like human brain that learns more and more with time and does not forget what happens before. It just gets better.
Is there any drift in the machine vision outputs that it's training on? Can you tell if there is such a thing?
What do you mean?
A drift in the data. I don't know. Maybe for some reason, internal bleeding around the stomach now is showing up differently than it did years ago. Maybe because people's health have changed or their average. Like, what if there's a drift in the data?
So this is something actually that's very, very, very interesting question. This is, I would call it bias in the data. It happens. There's always a bias. And that's why we always need human input and we always need to retrain those models and validate that they're working right. So that's, I would say, why we still have human input and it's not just 100% automated and we stopped training right now.
How do you identify bias? How do you, like, what's an example of some bias that you've seen in your models where you have to figure out where it came from?
So, for example, let's say if we looked at, let's take a simple example. Let's look at blood cancer. So you have the cancerous cells, and sometimes regular cells, the model can recognize regular cells as cancerous cells by mistake. This can happen. So here it's very important that we still have expert input, and we do validate the model and make sure that those false positive are marked as such, and then we retrain the model on eliminating those false positives.
Okay. I mean, how many of the scans do you look at manually to see if it's a false positive? Is it every single one, or is it only?
No. It's usually there is ongoing process of validation going on. So the experts always look, the data science team usually always looks at the outputs of the models or certain subsets of outputs of the models and validates them if they are correct. Methods.
What percentage of scans, for instance, for internal bleeding are looked at manually? Statistically, what would be enough? 1%? 10%?
So this would depend on the model and depend on specific use case, but it can be anything from 10% to, if the model is performing well, it can be less than 1%.
Okay. So again, you've gotten it to a very high efficacy. Do you see it getting better and better still, or?
It's always going to get better and better.
It is? It's always going to get better?
I believe so. At least so far, because think of it, there are always edge cases, there are always new things that coming up. So
Well, there's also overtraining. I mean, there's getting stuck in a localized minimum or maximum. If a feature tends to dominate what's seen in the visual field there. I mean, I know there's overtraining. So how do you make sure the model doesn't wander into bad territory? How do you tear the weight, or how do you zero it out or make sure it's resetted properly?
So when the models are trained, usually when we start training a model, we feed it a certain number of scans. After some time, we need less and less training, but we do need training for edge cases or new things that come up. So I would say never.
Or an outlier, like what do you do with space? They're outliers.
So that's where we need to have human input, and then we teach the model as would an expert in this field would do. They would learn what it is and explain, basically create the training data that outlines this edge case to the model.
What's an example of it?
For example, new types of tumors, for example, or if you're going to the same ultrasound where let's say the organs we're looking at look different, completely different, or it's a person with results that haven't been seen before. In any type of data, edge cases happen. And that's the thing about edge cases. We can't predict them. They just happen. And when they happen, then we deal with them.
You don't just delete them. I would think you would learn from them. But do you not include them in the training data, or what do you do with?
No, we have to include them.
Well,
yeah. So in this case, we identify it as an edge case, or the model fails. Like the model basically says, like, okay, I don't know what to do with this. This looks different. Then we have experts, let's say radiologists or number of experts that look at those edge cases and they decide what it is and mark it as what they decide that it is, and we use that as a training data for the model.
Okay, are edge cases particularly useful? Are they dangerous?
Are extremely useful. They're essential to keep the models up to date.
Why essential? How are they useful?
Well, if you encounter something new, you want the models to learn that something new exists. And if they encounter this again, they will know what to do with it. So,
So what kind of edge cases would you get with internal bleedings, for instance?
well, it's kind of hard to answer this question. Like, it just doesn't look like it's a bleeding. Like, it's like really specific, but let's say it doesn't look like it's a bleeding, but it is, or vice versa, like false negative or false positive. It can go both ways.
Okay. So, I mean, do edge cases tend to support false positives or false negatives, or
it's really
random?
It really depends. There is no rule. It can be anything. That's the whole idea for edge cases, that we know, like, you never know what it is, but when you encounter it, model fails, then we have to like train the model on those edge cases as well. But it can be.
Maybe there's a skew in the edge cases. They're not symmetrical around the main data. Maybe that would tell you something.
Well, long tail, yes, but again, so it's important for model training.
Okay, so so you use AIs now to detect, let's say, internal bleeding when someone comes into the hospital. What else are they being used for? The vision sense.
Oh, there are actually so many applications. It starts from recognizing pathology on the scans, like any type of scans, to cameras in hospitals or camera in elderly homes that ensure that the people are well, like recognize, let's say, if it's an elderly home, the camera, the smart camera, of course, there's like full privacy to that, but the smart camera would be able to see if the person, say the elderly person in the house, having an issue or they're having a heart attack or he fell down, basically motion recognition as well, or they need help. So instead of basically a person to press a button, call for help, the camera would recognize it right away and call the ambulance, call the support. So it's everything. It's really helping to, if you're looking specifically at elderly care, it's really helping to improve the life and save lives of elderly people, because instead of...
Well, how do you know? Is it in use or is it still being tested?
Yeah, it's in use. It's been in use. It's been in use actually for quite a while. It's getting better and better, especially for motion recognition or action recognition. It's usually it's autonomous cameras that are deployed at people's houses. Multiple companies, let's say multiple service providers that do that, but the idea is this camera, fully autonomous, that can recognize if the person's having like a heart attack or stroke or like anything is wrong with them, and then it calls for help right away.
Where are these? Only in hospitals or?
You have them in hospitals as well. You have them in private homes. This is like a service, like you have a security camera in the home. It's a choice of, it's like people's choice to use the services or not.
Some people just have it in their home?
Yeah, some people do. Like this technology has been around for a few years already. Of course, it's getting better and better, but more and more people choose to use that in their home. It's like having a smart camera facing outside, detecting motion, but the same thing, but more sophisticated, fully private inside.
Well, what companies produce this? Where can people get it, for instance?
That's a good question. So I will not be able to answer that. But I'm sure if you search for like even the ChatGPT or Google cameras, smart cameras for elderly care, there are multiple companies that do that. Now, we like Keymakr, we are a service provider for creating the training data. So we will be on the other end of those cameras. We will be helping to develop and train those models, but we don't sell them. So like kind of going up the development chain, we would be like the building block of creating this AI, and then multiple companies, multiple camera companies or healthcare companies that would purchase this AI as a service together with the camera if needed and deploy it under their brand.
Many other interesting examples of work that you've done? No, that uses AI to diagnose things. Any other examples?
There's so many. Let me think for a second. What else is really interesting? I would say one of the examples I personally really like goes back to what I mentioned before, is X-ray or MRI recognition. If there's any issue, let's say broken bone or internal bleeding or tumors, etc. But the way it's used is in remote locations. So you have, let's say, an X-ray scanner in a remote location, either in places that are just, say, far away. There's no hospitals there, no doctors there, but there's like a little station or the medic station with like scanning device. And instead of having or waiting for a doctor or transporting yourself to a hospital, the diagnosis can be done right away at the spot. So it really enables fast and cheap healthcare in a way in remote location. Now, the most important part of the health, like of helping somebody, is understanding what's wrong. And here we immediately understand what's wrong and even remotely choose the appropriate treatment for that person. So it really helps to help people to get proper health care in remote or locations where nothing's near there, no hospitals, no anything.
Okay. What's the best way for people to keep tabs on your work? Where should they go?
Well, again, like Keymakr, we're not like the end product creator. We're just a building block in creating those models. So nothing really, but there's always like new things come up in healthcare. So just, general stuff.
Okay. Well, very good. Well, thank you for coming on the podcast and explaining. I really appreciate it, Maria.
Thank you.
Thank you for listening to the Good Question Podcast. Please email support@thegoodquestionpodcast.com if you have any referrals to great guests for us to interview. Visit thegoodquestionpodcast.com to hear more interviews. And please help us spread the word by rating and reviewing us on Apple Podcasts, iTunes, Spotify, YouTube, or wherever you listen to this podcast.
Again, like Keymakr, we're not like the end product creator is just a building block in creating those models. So nothing really, but there's always like new things come up in healthcare. So just, general stuff.
Okay. Well, very good. Well, thank you for coming on the podcast and explaining. I really appreciate it, Maria.
Thank you.
Thank you for listening to the Good Question Podcast. Please email support@thegoodquestionpodcast.com if you have any referrals to great guests for us to interview. Visit thegoodquestionpodcast.com to hear more interviews. And please help us spread the word by rating and reviewing us on Apple Podcasts, iTunes, Spotify, YouTube, or wherever you listen to this podcast. Spotify, YouTube, or wherever you listen to this podcast.